Okay, so we're back in process directors, and remember we've got two of these loops. One's handling events, one's the main processing loop. And now I'm going to talk about what actually happens when we process the command directors. So if we go in here, and very quickly, just to recap, we take all our command directors and we're iterating over all of them through this through loop. And for each command director, we check whether it should continue or not. And if it should, then we're going to process it. So we're going to process its commands. We're also, if it's the end of, if it's the last command director, we're going to wait. This is an attribute we can set on the interaction processor as we start the interaction. Now, having processed all the commands, we are continuously updating the array of command directors. Remember, these are all copies. Every time there's a tunnel, there's a copy, and so what we're doing is collecting any changes that occur to a command director, because we need to write them back so we don't lose them. And then the next state after processing is to continue. Okay, so when we process the commands, so the command director, it's just one command director at a time. We grab hold of the commands that have been associated with that, and we process each one of them in turn. If it's the last one, then we've also got a wait time, just as we do for between the command directors. There's a wait time between the commands, and each command has to be processed. And again, having been processed, there might be some changes, so we need to gather those changes together through these shift registers to write them back in to the command director and increment the run count. So the command director, the single shot command director, having run all of its commands, it can tell because of the run count, the others will continue to run until they reach their specific rule for having finished. Okay, so processing. So here we're going to process a command, and this will depend on whether it's the write command or the read command that we're looking at. So let's just have a quick look at the write command. And here we've got the write command comes in, we prepare to execute it, we actually execute the write query, and then we execute the post execution call out. And this is a bit of code that you can write in to your actual command to do something specific after it's actually written to the instrument. And when we prepare to execute this, assuming there are no errors, we have this, a pre-execution call out. So same thing, you can add your own code in to do something specific for the command before it actually runs. We have to go through and update driver settings. So this is configuring the instrument. So this isn't command parameters, it's actually configuration settings for the instrument itself. We're going to initialize the driver and commit these driver settings to it. And this act of committing will basically just make sure that we only apply the driver settings the once. And we need to, because we've changed the driver, we need to just save that and write it back into the command. And the executable is an interface that allows the driver to talk to the command to get the actual command string it needs. And we're passing both the write command and it's a copy of itself as an executable. The executable has just the commands that it needs, that the driver needs to ask for the actual string to send to the instrument. So once we've prepared to execute that, we actually do then execute the write query. And in here we're getting any attributes that are specific to the command itself, and these are driver independent. The driver itself should be able to convert these to settings that it understands. What we pull out of there is an indication of whether we can overlap, so whether the commands can run simultaneously instead of waiting for the previous command to finish, whether we need to block all the threads whilst it's waiting, so that everything is just waiting on that previous command to finish, and a timeout value. We're also pulling out the visa session that we would use to write to, and as long as if we don't need to overlap, then if we can't overlap, then we obviously need to wait for completion. If we can overlap, then we can just run straight through because we can run the command straight away. So let's just have a quick look at this. And here what's happening is we've got our visa session in, and we're writing a Scuppy CLS command and an OPC command, and these effectively just commands that are part of waiting for previous commands that are still running on the instrument to finish. And here we've got timeouts, and what we're interested in here is whether it says here, so we're checking if we're completing every 50 milliseconds. So instead of just constantly asking the instrument, we check and then we wait 50 milliseconds, we check, we wait 50 milliseconds, and that's what's going on here. And once I mean, eventually it'll either time out or and we'll raise an error, or it will actually report back that it's completed and we can stop the while loop that's waiting for that condition to happen. Okay, the ESR and the OPC commands are explained here. And you can see that the ESR is the command that's actually being sent to determine the current status of the instrument. So we're waiting for that to complete if it can overlap, and then we build the command, and this is in this case on the right command, and we get the base command. So for example on this one it's a get ID, so we'll get the star IDN. I think this would actually be on the first, so this right command would be the reset, the star RST. We determine if there are any parameters for that command, and we are then building up the actual string that we need to send to the instrument. So in this case we'd get the star RST. There are no parameters to that, but these would all be then automatically added. Here we're iterating through the parameters. We're adding a space or a comma to them, depending on whether it's the last one or not, and then finally adding this /n, which is effectively the terminator character for the command. And so we should end up with something like, in this case, star RST /n out here. We've built the command, and then we write it. So this is visa write. We write that command through the session, and we're done. We're not expecting a response because it is a write command. So once it's written, that's actually it. That's actually done. Let's have a look. If we have to look at the difference with the sorry, let me just find that on the read command. We're going through pretty much just a similar initial process. So we're preparing to execute, and we then execute the write read query. This is exactly the same as the write. and in here, as you saw before, we execute the write query. We've got a query to write onto the visa session, and what we're pulling out of here is a byte count and a parameter count. These are counts that we that drive the visa write here, and it's waiting for a number of bytes to read back out of the instrument's buffer as a response. The parameter count is going into the parse results here. Now when you send a parameters, if your command includes parameters, you're going to get a response for the command that you write, and you're going to get a response for every parameter that you send through as well. Parse results will then go through that, and it will, for every parameter that was there, it will parse out a result and store it against the parameter. This is what all of this is doing. So it'll do that for every parameter, and it will also store a result for the command itself. And they're all stored. So each parameter, which is an object in its own right, will now have a raw result, and each command will have a raw result. And the raw result is basically just a string format that comes out of the buffer. So here, we've sent that, and we've got a raw result for the command, and we've got an array of raw results for the parameters. And we store those raw results, and we store the parameter values. And here we work out how to post the result back. So if we've passed the results notifier in, this will actually be carrying a value, which is one of the first things we check here. So if we pass the results notifier, we check to see if something is waiting to be notified. And if you cast your mind back onto the interacting application, the results notifier loop, the results handling loop, sorry, the first thing that is doing is waiting on the results notifier. If nothing's waiting, well, in this case, if nothing is waiting, what we do is we actually send a message onto the notification queue, a result message, and we enqueue that. Sorry, let me just go back to that. What we're passing in is the read command as the data on this this message that we're passing in. So the read command will have the results embedded within it, and it can then be pulled out when we do the result handling in the main processing loop. If there are if there is something waiting on a notifier, what we do here is we raise that notification, and again we're passing the read command in as the data for that. So this is just the difference, as I've explained before, of results notification can happen immediately. If it's actually sent as a result message, it will have to wait for the end of all of this processing to be able to be processed. And then finally, we run any code that we write that we want to, that's specific for this command, after we actually run it against the instrument. The callouts are just a bit of flexibility to allow you to affect some of the processing as you see fit. So there we go. We processed that command, and we're back processing the next command and the next command and the next command until we've done them all. And if we come back to here, we've processed all the commands and the command for the command director, and we've processed all the command directors, and the next thing is to continue. The next state within the main processing loop for the framework is to continue. And I think I have covered this in the last one, just briefly goes through it. So this is just checking whether the interaction processor should stop or whether it should keep going. And if it's been told to handle injections, it will always keep going. Otherwise, it will check to see if there are any command directors left to do something. So if should continue is true for at least one of the command directors, then the interaction processor will keep processing. As soon as it's finished, it will signal a done state. So that's actually what's going on with inside the framework to run a command. It is quite Scupy focused at the moment, but as this framework evolves, some of those very specifics will get abstracted away, so that it becomes a lot more simpler for users of the framework to actually create and pass in their own commands without having to worry too much about whether they're dealing with Scupy or very Scupy focused elements. I'm hoping that was clear. It's obviously the best thing to do is to try some of these examples and step through them and see exactly what's going on. But what we've covered off here is how the framework is actually running and processing those commands for this particular example. The future videos that I do on examples won't go into anywhere near this level of detail. You'll be glad to know.